Okay, let me show you how to work with the binomial distribution. Okay, both with the formula and with the GDC as well. So it's written as follows. So the symbol is X follows a binomial. The B stands for binomial. Now you see that online, some people like to use BIN for the binomial, but it's the same thing and it doesn't really matter. So you could actually write it as X follows binomial NP or X follows binomial NP, okay, in the same way. Now, what's important is that you need to understand what the N and P stand for. So the N stands for independent trials. So you basically have one experiment which is done multiple times, okay? And in this case, it's being run N times. And then you have P, which is the probability of success. Now you have N independent trials and the probability of success is the P, and in this case, actually the probability of success is fixed. Okay, fixed, or we can say that it's constant. All right, so you're basically running an experiment whereby you have N independent trials and you have a fixed probability of success. One very simple example would be if you're tossing a coin. So let's say you're tossing a coin 10 times. Okay, so you have 10 independent trials here. And we say independent because each toss is independent of the previous one, or all the different tosses, so all the different 10 tosses, they don't really depend on each other. They are quite unique on their own, so they are independent. All right, so you're tossing a coin 10 times, and let's say the aim here, so the X is the number of heads. Okay, we get out of 10 tosses. So let's say X is the number of heads you get out of 10 tosses. The probability of getting a head on each toss is constant because it's half, and probability is half every time you toss a coin. So it's a fixed probability of success, and you have 10 independent trials. So you can use a binomial distribution to model this situation here. Okay, so it's going to become X follows binomial 10 half. That's how you're going to write it, and X can actually be 0, 1, 2, up to 10. So you need to define the different values of X the distribution can take as well. So it can't exceed 10 because you're tossing 10 times, so the maximum number of heads you can potentially get is 10. And the minimum number of heads you can get is 0 because you could be tossing the coin 10 times and you get no heads. So it's going to lie between 0 and 10. And most of the time, X starts with 0, but there are some cases whereby it can't. For example, if you're rolling a die, and X represents the score, then the score can't be 0. So it will depend on the context, but in a binomial situation, X can be 0. So let's say X is the number of ones you get when you're rolling a die. You could be rolling a die and you don't get any ones. For example, if X is the outcome that you're getting a 1 when you're rolling a dice. It could be that you roll a dice 10 times and you get no 1. So by definition, X starts with 0 and it ends with the value of N here, which is the maximum. All right. Now you have a formula to calculate the X. So it's X equal to R is equal to NR PR 1 minus Pn minus R. So that's the formula we use to calculate the probability of X. So let's say the aim is to find the probability that we can get 2 heads, okay, out of 10 tosses. So it's going to be NR. So the N is actually here. So that's N, that's P, this is R. So one thing you can do is you can actually label the different things. So NR would be 10R, 2 sorry, p which is half, so it's half power r power 2, 1 minus half, n minus r, so here r is 2, it will be 10 minus 2. All right, so that's what it's going to be. Now 10 2 is 10 NCR2, you can do it manually, it's 10 times 9 over 2 times 1. Half to the square is 1/4, and this is half to the power of 8. So 2 goes into 10 5 times, so it's 45 times 0.25 times 0.5 to the power of 8. And we can actually try to do it on the GDC. So I choose the normal math mode, and I do 45 times 0.2, sorry, times 0.25, because that's a 1/4. So times 0.5 times 0.5 to the power of 8. All right, just check again whether we've written everything down. Yeah. So we get 0.0439. Okay, so that's how you work it out if you have to do it manually. Now let's say we make the GDC do it. So if we make the GDC do it, we need to go on the menu, choose the stats mode, and then we look for distribution. The distribution is here, and that's F5. So you press on F5, it gives you different distributions we can use. We're going to choose binomial here. This one, BINM. So F5 again. Then it gives us BPD, BCD, and inverse binomial. We're going to choose BPD. The D stands for discrete here. And we're finding x equal to something, so it's a discrete value. So BPD, we enter. So x, the data is a variable. We're not taking values from a list. The x is what we're trying to find. So here x is 2. So I'm going to input 2. The number of trials is the value of n, so that's 10, because we had 10 trials. Okay, here. The P is the probability of success. So probability of getting ahead is 0.5. So I'm going to write it here, 0.5. And then execute, I go down. Then I want the calculator to actually calculate it, so enter, and it gives me 0.0439. So you see, so we can actually do the binomial PD, okay, and it gives us 0.0439. Sorry, 0.0439. So you can actually do it using the formula, or you can use the GDC to get the same answer. Now, it's quite possible that it becomes a bit complicated and you need to calculate multiple values. For instance, you may need to calculate probability x less or equal to 2. Okay, if that's the case, you need to do probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. All right, so you need to work out the probabilities 3 times. So you'll need to actually use this formula 3 times and do them manually and add them. But if that's the case, then it's usually a wise decision to use the GDC and not do it manually. And if you are an AI student, you have the GDC for both papers. So then there's no point actually doing it manually like that, because here, if I have to show you what you need to do, it's quite long. It's 10, 0, 0.50, 0.5, 10 minus 0 plus. Then you do the same for this one, 10, 1, 0.51, 0.59 plus 10, 2, 0.52, 0.58. It's quite long. You need to do 3 times. The clever thing to do is to actually use the calculator again. So the calculator actually can calculate individual values by using the PD function, or we can actually ask the calculator to run a cumulative one. So I go on the distribution again, I choose binomial again, Okay, F5. Then it gives me BPD, BCD. The C stands for cumulative. It's when you're doing less equal to something. So I'm going to choose the BCD one. Okay, you see on top here it writes CD now, meaning it's doing a cumulative. So we need to work out x less or equal to 2. So it's still variable, and we are doing less or equal to 2, so the x is 2, okay, because we're doing a cumulative as from 2 going down. Number of trials is 10, fixed probability of success is 0.5, so everything seems to be fine. Okay, that's okay, 10 is okay, 0.5, that's fine. We execute, and it gives us 0.0547 if we give to 3SF. So that would be 0.0547. Okay, using the GDC. So here we've used binomial CD with the x value being 2, which on the calculator you're putting 2, but the calculator is doing x less or equal to 2. Okay, so that's how you can actually learn the formula in binomial. That's how you can apply it over here, and all of that can actually be done using the GDC. Okay, you run binomial PD. If you need to do a cumulative one like this one, less equal to 2, you do it the manual way, it's quite long, or you just run a binomial CD on your GDC, and the binomial CD does less equal to that number.